Our lesson today is about the standard normal variable, and our memory verse is found in Exodus 18, verse 26. It says, "They judge the people under normal circumstances. The difficult cases they would bring to Moses, but every small case they would judge themselves." Your MBCA boosters today is very related to our memory verse. Why did Moses only judge beyond normal cases? At the end of this lesson, you'll be able to convert a normal random variable to a standard normal variable and vice versa. And the first student to give the correct answer in our venture activity will get an extra point. It is asking you, what is my Z value, or what is my Z score? Now let's start by differentiating population and sample. What is a population? A population is the set of all. We say the word is all. That's the key word. Of all people, all objects, all events, and all ideas, while a sample is a subgroup of a target population. Let me illustrate it this way. If this is your population, that's the whole thing, then we get only a part, then this is called sample. Again, population refers to all your target respondents. While if you say sample, it is just a part. For example, the population can be all teachers of Valencia City, and the sample will only be the group of private school teachers or the group of public school teachers of Valencia City. Another, the population can be all MVCA students, while the sample can be just the grade 11 class. So that's the difference between a population and a sample. Now let's define a standard score or a Z-score. The standard score or Z-score is the equivalent value of a raw score using the mean. We symbolize the mean as X bar and the standard deviation, sigma, of the distribution. It measures the distance of any particular raw score from the mean for a given standard deviation unit. Now we might ask, why do we need to compute the Z-score? For example, you're taking an examination. You're taking the entrance examination. And this is how we usually see it. 0, remember, is the mean or the average. Now, based from the average, what is your standing in the entrance examination? Or for some, they do it this way. We admit students only with a Z-score of -1 and above. Those who will be -1 below -1, will no longer admit them. Now, you might ask, what if I've taken the examination with intelligent students? So the 0 or the mean will be higher compared to taking the exam with not so intelligent ones. It's true, especially if the examination is in a percentile. That's why they say you need to analyze first what's the trend of the examination and what's the trend of the takers. Now, here are two formulas. Actually, they are just the same. The difference is the notation. If the given is a population data, the Z-score is computed as, let's learn to read symbols, X. X is your raw score minus mu. Mu is the population mean all over sigma. Sigma is a population standard deviation. If it's for sample data, we'll have the same formula, x minus x bar. X bar refers to the sample mean all over S. Now, how do we do it? How to solve z-scores? First, identify the formula, the first one or the second one. Second, check the given values. Third, solve. And fourth, compute for the z-value. And after you compute it, you need to interpret the z-score. If the z-score is exactly 0, it means that the score is on the average. If it's below 0, it means it's below average. If it's greater than 0, it means it is on the above average score. For example, let's take example number 1. In example number 1, the given is mu is 50. Give me a minute first. Mu is 50, sigma is 4, and thus x is 58. Step 1, we need to have the formula. Based on the given, this is within a population because of mu and sigma. So the formula for our z-score is x minus mu over sigma. Let us solve. X is 58 minus mu is 50. Our sigma is 4. So 8 divided by 4, our z-score is 2. If you're going to draw that in a normal curve, it's here, right? 2. Therefore, with a z-score of 2, it is in the above average category. Let's have the next example. The next example is about the scores in PE. Now, the given, that's 39 is the score, the mean is 45, and the standard deviation is 6. There's no notation, whether it's X bar, mu, sigma, or S. So there's a note. If the problem does not indicate symbols, we assume it's within a population. So let's solve for our z-score. Z equals x minus mu over sigma. Our x, our raw score is 39 minus a mean of 45, all divided by 6. That's negative 6 divided by 6. Our z-score is negative 1. It's a negative number below 0. So it's categorized as below average. Let's go to example number 3. In example number 3, it's very clear in the given, X bar and S. So it is within a sample. To solve for Z, we have X minus X bar over S. So our X bar is 26. Our X is 20 all over 4. That's negative 6 divided by 4. So our Z is negative 1.5. It's categorized as below average. And let's have the last one. Am I going too fast? It's very easy, right? In the last example, DG Company has 100 branches nationwide. The DG Company's annual profit is normally distributed with a mean of 73 million a year and a standard deviation of 3.25. How many branches have a profit of 73 million to 80 million? Now we are asking how many branches. So what do we do first? We first solve for this one, the z-score for 73 million and the z-score for 80 million. Now remember that 73 million is the mean. So the z-score of this is 0. In the next, how about for 80? Let's solve the z-score for 80. We have x minus x bar. Why do I say sample? Because it comes from 100 branches. So it's only the sample for them. Minus s. That is x. 80 million. I'll just place 80, okay? Minus 73 all over 3.25. The z-score for 80 million is 2.15. Now, what's the question again? How many branches? If we draw our normal curve, it looks like this one. From 0 to 2.15. We're looking for the area of this one, from 0 to 2.15. Now you get your z table and let's solve for it. The area is 0.4838. What do we do with this one? The area, you multiply it to the total number of branches. So we have 0.4838 times 100. We have 48.38. However, it is talking about branches. So the answer should be a whole number. What do? You drop the decimal. Ma'am, what if the answer is 48.75? Do we need to round it off? No, just drop the decimal. So the answer is we have 48 branches whose profit is from 73 million to 80 million. What if in the example, the number of branches is 500? Then simple. You multiply 0.4838 by 500 if it's the total or the population. Now, do you have any questions?